Dear students, welcome to KV's Science Classroom. Today we are discussing electrostatics, which is the first chapter in second PUC. Now here I have selected 5 points. Those are very important here. Now these points are such that you can understand these points, which helps us to know the first part of this electrostatics. Now you can see this is first point is what is electrostatics, or what is the definition of electrostatics here. Then second point is what is meant by electrostatic charges. This is the second point here. This is what is meant by electrostatic charges. Then third point is the electrostatic charges should be represented diagrammatically. That means how to represent the electrostatic charges. This is our third point. Now coming to the next point, that is two important properties. You can know we must know the properties of that one. What are the two important properties are there now? Now these are the two important properties we wanted to study. Then by knowing all these things, the name called as Coulomb's. Coulomb's has given a law. It is named after the Coulomb and it is called the Coulomb's law. We should know what is the Coulomb's law. Then finally, what are the drawbacks of Coulomb's law? The law is a fundamental law, but it has got some drawbacks are also there now. Now we have to discuss the drawbacks of this one now. Now all these 6 points we can discuss one by one. That means first is what is electrostatics. Second is what is meant by electrostatic charges. Third is how to represent the charges now, representation of the charges. Fourth is two important properties of electric charges. Fifth is Coulomb's law. Coulomb's law tells us how to measure the force between the two charges now. And last is the drawbacks of Coulomb's law. Let us come to the next slide now. Now our next slide is what is electrostatics here. Let us first discuss what is electrostatics. Or you tell me what is meant by the electrostatics, or what do you mean by the electrostatics. Now this is defined as it is a branch of physics which deals with study of charges at rest. Now let us see this point very well now. Now you can see this point now, and you can say there the charges are at rest here. Now you can say now here the charges at rest. Now I hope you can understand the charges are at rest here. That means you can tell me, that means here we are discussing the statics of the charges at rest are there now. The 3 figures we have taken, the 3 figures are such that now you can see the figure. The first figure is here now. You can say this is the positive charge now. That means what happens now? The positive charge, just you closely observe this. Now similarly, the second one is that it is called negative charge. This also you can observe here. Then these two figures are there. What is positive charge now? That is shown it like this here. It is bigger figure now. And likewise the negative charge is shown by another figure here. That means you can see the figure here. This is for the positive charge and this is for the negative charge. The representation now. Let us understand there are only 2 types of charges now. It has been experimentally proved. That means there is no any other charge, any more charges are there, only 2 types of charges are there now. And you can see that one is called the positive now. The positive can be shown by like this and negative can be shown by like this. To more elaboration of this representation of charges now, let us take here the another figure. That means actually what happens now, you coming to this slide. You people can very well observe here. You can see this charge is coming from here and going to this charge now. I hope you can understanding here. The same thing also, the positive charge is directed towards the negative now. This is arrow mark is here, this arrow mark is here now. That means the charges, positive negative charges, you very well you can classify by the lines of forces directed away from the charge. This is for, you can say here it is a, this is for positive charge now. They're going towards a negative charge, this becomes a negative charge now. That means positive negative charges are there now. They can be very well classified by the lines of forces directed away from the charge, it is positive. The lines of forces directed toward the charge, it is negative now. Now this figure shows this is your negative charge and this is your positive charge now. Now there are only two types of charges are there. Experimentally proved. These charges may attract or these charges may repel. The like charges and unlike charges. But representation of that can be done by the lines. You can observe here the lines of forces are there. They are away from the positive charge, and for negative charge they are towards the charge now. This is actually we people have to represent diagrammatically. They are positive and negative charges. Now let us take, now these charges are there, they are attracting and repelling now. Now how much force is there in attraction? How much force in the repulsion now? And how to measure this? Now this can be done by a very popular law. It is called as the Coulomb's law. The Coulomb's is there now. This is the name of the scientist now. The who has given this law? Coulomb's, and the law is named after the Coulomb's law. Now I can say here in this figure, this is positive charge, again this is also positive charge now. Now these are called as a like charges. Then what happens now? The force is away because it is a repulsion here. Now you can say this is also away, this is also, this is a repulsion. Now you can say here is also repulsion, that means like charges are there, they repel. Remember, the like charges repel each other. They may be positive or they may be negative. Coming to this one now, second figure, you can say one is positive charge here and one is a negative charge now. This I show, this is nothing but it is the attraction now. And this happens to be, this is attraction because there are unlike charges are there. Unlike charges attract each other. Now it is clear for you people, there are only two types of charges are there. Either they attract or they repel, depending upon the like charges repel each other, unlike charges attract each other. Then the Coulomb has given the law. It is called a Coulomb's law. Now what the Coulomb has told now? The force of attraction or repulsion is that it is proportional to, you can say Q1, Q2 now. Now this is called a product of the charges now. Q1, Q2 now. And this force of attraction is there proportional to 1 upon, this is a d square, or you can say this is a d square, or it is also called the r square now. Proportional to square of the distance between them now. The combination of this one, you can find that F is equal to K into Q1 Q2 upon R square now, and this K is their proportionality constant, and this value the K is equal to, you can say 1 upon 4 pi, this is epsilon naught now. That this is whole equation itself is called a Coulomb's law, and the statement of the Coulomb's law is, the Coulomb's law states that the force of attraction or repulsion between the 2 point charges is directly proportional to the product of their magnitudes and inversely proportional to the square of distance between them now. Now this is, in conclusion, you can say that this law helps us to measure the force of attraction or repulsion between the two charges. That means this is known as a Coulomb's law. Now Coulomb's law is the law which helps us to measure the force of attraction repulsion now. Now I understood the charges now. What is electrostatic? What is electrostatic charges are there? How to represent them? And you also understood the like charges repel each other, unlike charges attract each other. Then what are the important properties of them now? What are the properties are here for this one now? Now there are two important properties of electric charge are there. First one is the electric charge is conserved now. That means I can say that is a conservation of electric charge. For an isolated system, the net charge always remains constant. is called conservation of electric charge. Now you can take any isolated, for example, you can see here there is one isolated system is there. For example, for this one, all charges are there here. This is a constant. This is, you can say, the charges for this one you can represent like this. Now all these charges are here. You can say that is a constant. That is called the conservation. It remains constant. Now is called the conservation of electric charges. Now this always remains constant. Now the second property is the quantization of charge. Now quantization of electric charge is the property by virtue of which any charge exists only in discrete packets of certain minimum charge. Now the minimum charge is how much here? Now you remember guys, the minimum charge is there here in this case plus or minus C. But by quantization of charge, charge on a body can be integral multiples of U now. That means I can write here, this is Q is equal to the charge now. It is either plus or minus, but N into E now, where this N is equal to 1, 2, 3, and so on like this. This is what now? Integral multiple of E now. Now this electric charge is there. This value of the electric charge, you can write it like this. For example, E is known to you people. That is 1.602. 1.602 into 10 raised to, now this becomes as minus 19 Coulomb. This is the E value is there now. Now this is how the second property explains that the quantization of electric charge is there now. This is the electric charges are quantized. They are available in integral multiples, but in brief they are not available in 1/4, that half and 3/4 and so on now. They are available only integral multiples now. These two properties are clear. The first property is electric charge is conserved. The second property is it is quantized now. Now what are the drawbacks are there now? Let us see the drawbacks here. Now we have mentioned the two drawbacks. The one is law is valid only for the point charges. That means the point charges are there. So far we written, for example, here it was a Q1 and this was written as a Q2 here. This is available for only point charges now, not for the bulk charges. The second is the Coulomb's law is valid for distance is less than, greater than, that means this value you can say this is, I can write it as a R greater than, they are equal to 10 raised to minus 15 meter. 10 raised to minus 15 meter is radius of the nucleus now. That you can say these are the two drawbacks are there. In this one, first one, this law is applicable for only point charges, and second one you can see that this law is applicable for the distances greater than 10 raised to minus 15 meter. That means this is, if you say for example this was a F force is equal to, I written this is a K is equal to right now 4 pi, this is a epsilon naught. You write here this is a Q1 and this is a Q2 upon this is R square, and that multiplied by unit vector here. Now this is what I written now. You can now call this is a vector form of the Coulomb's law now. You can say it is a vector form of the Coulomb's law. That means you can represent the vector's law, the Coulomb's law in terms of the vector form now. Now coming to our today's last slide, you can observe here, dear students, I want to bring it to your knowledge. The physics is, in case physics is affecting your preparation now, you feel the physics is difficult one now. Do you know physics is a score deciding and rank deciding subject now. Whatever the score it happens, whatever rank you can avail or you can get now, that depends upon the physics subject. Now more students struggle a lot today to score in physics now. They find physics very difficult now. They not even touch the numericals. They move away from the numericals now because they lack clarity in solving numericals. They don't know how to approach physics numericals. That is why there is the point-based physics is possible now. You have to study physics such that the concept is clear. Your approach to the numerical must be very expertized now. So if you see the toppers, those who are scoring like this, 20 out of 720 now, we become astonished now. How they score it now? They're working rigorously for 2 years under able guidance. They stand top to the nation and they can bring their dreams come true now. You too also can compete for these people. You too also can make your dreams come true now. Now I hope you people can read this slide now. Now we are giving 2 years online and also offline coaching for Neet and Kcet, and I hope that you people also can target your dream. You can make a dream of getting 720. This is of 720 only. This is possible for you people, and you people just join us and make your success one grand now. Thank you for watching this video. I'll thank you people on behalf of KV's Classroom. You like this channel, you share this channel, and you subscribe this channel. Thank you one and all.